That's F5 or Facebook?
No, that's F8 usually for Facebook.
Okay.
Oh, there we go. All right, I'm Paul. I'm from Facebook. I work on the infrastructure team. Thanks for having me again this year. Last year we talked about our IPv6 only deployments internally. I came and I basically told you where we were, and we're gonna talk about from then until now what's happened. We'll recap some more issues that have crept up, and we will talk about some interesting stuff that we're seeing on the actual public internet today versus the internal data center stuff. So what exactly has happened? So we've done something what we call like the FB style IPv6 only data center. So this is where we're basically pushing machine-to-machine traffic is all v6. Every host in our network is dual stack. We don't have a single piece of infrastructure that cannot be addressed via v6 today. We deployed a bunch of clusters. So a cluster is basically a physical unit of work. So we have front end and what we call back end clusters, service clusters. Front ends where you go to www.facebook or m.facebook or graph.facebook or whatever Facebook. That's where those are processed. That's where the PHP code lives. That's where HHVM, which is our PHP runtime, and web server live. The service clusters are where we put like Memcache, Tau, newsfeed, ads, various different things that can be shared among many front ends. So it's a way of us scaling things. And then we also did something really huge is we've moved our development systems to v6 only. So we have the problem of engineers going up, writing code, and they don't think to write AFINet 6. They are still trained to write AFINet, and I was like, screw that. Let's just break the barrier. And it's actually kind of cool because last week, for the first time ever, I got a bunch of code in my inbox to review, and I was like, oh, great, here's somebody I'm gonna have to go through, find, oh, okay, you're not doing your v6 here, whatever. And this was 100% v6 only. So this is the first time I've ever gotten a new code, somebody wasn't modifying anything. They literally wrote everything new from the very beginning as v6 only. So I thought that was a pretty good thing for us. And then I put the VPN thing as a little aside. We actually had a VPN that didn't support v6. They tried to deliver us v6. It was pretty terrible. So we had to switch. We enabled it a couple months ago, and then people started complaining because they couldn't, stream their movie to their TV over Chromecast or AirPlay anymore. And the reason for this is we tunnel everything back to our data centers, and so v4 was only being tunneled. So v6 was working on their local LAN. And then it didn't work when we started tunneling the v6. So let's look at some of the numbers. So we're greater than 90% of our internal traffic is v6 today. That translates to roughly greater than 100 terabits a second. So that's quite a bit of data. And we should be somewhere at 100% by the end of this quarter. Now you're going to go, you're Facebook. Why aren't you 100% yet? Don't you guys move fast and break things? So yeah, I wish we were actually at 100% today, but last year we were focusing primarily on bringing up our front-end clusters on v6 only, mainly because these are the smallest number of dependencies, the fewest issues that we felt that would come up when we actually deployed. It's a lot easier to say, okay, my web servers talk to these things instead of, oh, I talk to these things and then these things talk to these things and then these things talk to these things, and it just, it would cascade. So the front ends were really the easiest for us to do. It's the thing that we bring up more of those than anything else. And so, when we were looking at how to do the service clusters, we thought, oh man, these are going to take way too much time, and let's just get the front ends done. And so the back ends actually turned out to be really simple. And that's mainly because all the groundwork we laid for the front end made it really easy for us to get the back ends up. A little story about last year when we actually were doing the first v6 only front end. We did it, it worked, everyone was super happy. There were quite a bit of issues, but we worked around them. And then we moved our attention to the service clusters, and I was like, okay, I'm ready to work on this, and nobody asked me for any help, and people just brought it up on their own. So it's like we had a lot of good internal messaging, a lot of, people just knew that this would happen. If teams weren't ready and they were given allocations of machines in these clusters, they just, in a couple of days, they brought it up. So, but the biggest reason we're not 100% is Java. So why is Java such a problem? Well, developers actively write code that disables v6. And I don't know how many of you write Java, but a lot of people just pass this property in and say, I'm going to just disable v6 for the most part. And this thing's pretty, this property is pretty dangerous. It basically makes it so you can't listen on a v6 socket. It just disables everything. So that's the problem. Then you'd want to look up host names. Well, by default, it prefers v4. So unless you use the API that returns to you all the addresses, if you just do a get host by name, it returns v4 only. And so you have to go through and modify all your code, or you can just do this. And then you get back the v6 addresses. So, it's something that's super annoying. It took our teams quite a bit of time to get it done. But, with everything said, Hadoop's about 75% done. That's pretty amazing considering that we forked our Hadoop many years ago. And the team worked pretty much nonstop last year to bring up. We have v6 only Hadoop clusters today, and they plan on being 100% complete here in the next month or two. And like I said, we believe we're the first HDFS cluster in the world running v6 only. And we're actually pretty proud that our engineers now think about v6 as a first-class citizen, and our Java developers aren't actively destroying code. Last year I talked about the biggest blocker for us was our rack switches. Well, 2 weeks ago, another rack switch issue came up, and it was pretty bad. And it affected our MySQL database cluster, which consumes a lot of terabits of traffic. And it was pretty bad because it would be every 4 hours we would see a spike in timeouts. And so you distribute this across thousands of machines, and we were just constantly throwing errors to our users. And it had to do with neighbor entries going from reachable to stale inside the switches, and they would just end up getting deleted instead of actually going back to a reachable state, because traffic is constantly flowing. So it's not like these things should ever be down, and things would blow up. So here's the way we fixed it. We basically ping every rack switch from every machine every so often, and it resets the state. And it's good because this would have been a lot of traffic. So I have this lovely graph. Can you tell me which side is the bad side and the good side? So this is where the timeouts are. This is the way the users react. This is where ping was deployed. And this is the way the users react. So, I think the key takeaway here is that we didn't default to saying, let's turn it off. We sat down with the network engineering team, we figured out a solution, and we moved on. Last year, I was sitting up on a panel, and somebody asked me, what about Orca RT or this thing? Why don't you guys have v6 on Messenger? You have it on mobile, you have it on blah, blah, you don't have it on Messenger. Well, I'm happy to announce that last summer, we renamed it to MQTT. Don't ask me what MQTT stands for. It's something the chat team deals with. The interesting thing is that on iOS, this just worked. We turned it on all iOS users. Nothing out of the ordinary happened. But on Android, we ran into issues. And it actually forced us to write our own Happy Eyeballs implementation for chat. The interesting thing is we switched the Android users over to mqtt.facebook.com, and we ended up getting reports of timeouts from users all across the world. We have a great feedback mechanism that people can report bugs back to us, and as soon as we turn this on, it would spike. And we didn't know if it was connectivity issues within the Android libraries, if some carriers were giving v6 addresses to the phones. We just didn't know, and it's really hard to debug these sort of situations when they're coming from Turkey, Brazil, we couldn't actually get all the information we needed. And it's also like kind of Java, so. So we launched this sometime in the fall. So Android is also, Android Messenger is also v6 compliant today. One of the other things that we did last year is we've made Facebook usable on IPv6 only networks. So, oh no, this is a different slide, sorry. This is why haven't we done our Quad ANS records. I'm happy to announce that this will be launching this half, and they're actually targeting to try to do it by the end of April. People ask me, why haven't you done it? It can't be that hard. Well, when you're trying to target users to go to like the nearest, POP or whatever, mapping the v6 internet is a little bit different than mapping the v4 internet. But it's not really a technical problem. It was really just like a resource issue, right? We have very small teams and they have, focus on other things, but they've assured me that they're going to get it done this year. Now let's talk about v6 only clients. So we did some work on our iOS client this last fall to make it work in v6 only environments. This was basically due to the examples that Apple provides on iOS and around their reachability APIs. They're pretty much v4 centric. They show you how to test for v4 reachability and how to do hostname reachability, but they don't show you how to do it for v6. The other interesting thing that comes up with this is when hostnames are used, it keeps some sort of state. So when you go between dual stack and single stack networks, it says you have connectivity, you don't have connectivity. And the reason why this is like difficult for somebody to say do a v4 reachability test and a v6 reachability test is a lot of times these are done on the main thread in iOS, and that ends up blocking. And so if you have to block for 2 or 3 seconds to test for both networks of reachability, you end up making poor user experience and you get 1-star reviews in the App Store. Same thing with Facebook Messenger. It was recently fixed last fall. Same thing, same issues as, it was using the same libraries. So one of the good things is that we're working on compartmentalizing this library and hoping to release it. A lot of iOS apps out there use something called AF networking that we're hoping to get integrated into AF networking so that nobody else has to deal with this problem. Because if you talk to Cameron over at T-Mobile, there's hundreds of apps that don't work on iOS because iOS doesn't do 464 XLAT, and therefore they all use these same reachability APIs and they all say the network is down and they don't work, or they use IP addresses directly. Somebody's going to ask me about Android. It's always worked on T-Mobile, and you've had to wait for Android 5 for it to work on but I've tested it at home and it works just fine. And then just to stop the questions about our acquisitions that are not doing v6 yet, I can't give any updates on that. I do know that they will get done, and the fact that we're forcing everybody to use v6 only development environments will make their code ready to deal with those sort of things. So let's talk about what it means to turning off IPv4 inside your data center, and how v6 only is not really v6 only at Facebook, but it is. So we have this problem of that there's this v4 internet out there that has to talk to a v6 only cluster. And we can't always push out all of our v4 internet traffic to our edge, which is where, is the logical place to try to, keep all of your v4 outside of your network and then carry it over v6 inside. So, we still actually have v4 in our switches, in our aggregation switches, in our border routers. It's still plumbed pretty much everywhere. The reason for this is that to do v4 non-RFC 1918 space inside of a v6 only data center, we needed to have a solution that required no special software, nothing that we would have to buy from a vendor, and that's completely stateless, simple, and uses current technologies. The other thing is that this is really only used for BGP peering and routing inside of the network. And then the one thing that we do is in every v6 only cluster, we use the same RFC 1918 block to address all of the network devices. So the hosts are v6 only, but the network is still dual stacked. But because we use these reusable blocks, we're not actually consuming any new RFC 1918 space in the network. One of the things that we did was, in order to carry traffic from a public V4 internet terminated host to the back end, we had to implement V4 inside of V6 tunneling, and this wasn't done in Linux yet. So one of our engineers did it last fall. It's been upstreamed, and you can use it today in the 3.18 and later. So I talk about, V4 in a V6 only network, and that's because nobody's really implemented RFC 5549. So what we did to work around this is we use V4 link local addresses on our hosts and our rack switches so that we can peer with them and then inject the non-RFC 1918 space into BGP so that traffic can then traverse into the network, and then the Linux host will terminate the connection, and then they will tunnel that V4 traffic to the backend web servers. So it's completely stateless, required nothing from anybody, and sorry, went a little too fast. And it was just something that we came up with because a lot of the transition technologies would cost us money, and this cost us nothing. And also because of the lack of RFC 5549, we've started deploying this fabric network, and again, our fabric network, even though we're carrying the majority of our traffic as V6, the peering sessions, they're still dual stacked. One's V4 BGP, we use our reusable 1918 space. V6 has its own prefix. And we're hoping to implement RFC 5549, but we may implement our own custom protocols, mainly because vendors don't really move fast enough for our own needs. Sorry, Mark. And so we developed these. This is Wedge and Six-Pack. These are our rack switches and our own custom aggregation switches. We also developed FBOSS, which is our own routing, our own software to run on these switches, and then we've open sourced all of this. We're hoping that this spurs more development and rapid development in the networking space, and all of this was built with V6 from the ground up. We actually forced them to do this because by the time they got around to running this stuff, there was so much V6 traffic, they had no choice. So now we're going to move on to what we see on the internet, and it's pretty statistics, and So what do we see on the internet? So we heard earlier that Google sees 6%. We actually see 9% of our total network traffic to the internet at peak is around 9%. So that's pretty big. We're looking at probably 10% in the next 1 to 2 months, hopefully. If John gets his act together. Since people asked me about Facebook Messenger, I threw it in there. It's at 3%. This is an interesting stat. Instagram, 12%. Don't ask me why. It tends to be, have more usage on V6 over V4. And, we see about a doubling every year. So we're hoping to close the year somewhere close to 20%. Oh, this came out terrible. So one of the things that I've been looking at, what do you want me to do? I don't know why it wrapped. Yeah. Whatever. One of the things that I've been looking at is, we see this data where V6 tends to outperform V4 in the mobile space. And so when you ask me, I consider the desktop dead. Sorry, John. And I think mobile is where the key concentrations for V6 are going to be. And so I've done a lot of looking at the data that we currently have, which is then spurring other projects within the company. So I take a look at one of the US mobile providers in the United States. It tends to be a dual stack provider. You all know who it is. I looked at the iPhone 6 on LTE only. This is from the server side, so we're not instrumenting the client here. And what I'm examining is how long does it take for a request? And Mark, he and I were having dinner 2 weeks ago in San Francisco, he's like, what does this actually mean? And I said, it's the time it takes for the device to read the response. And the easiest way to say it is I make a request to Facebook, it sends me the news feed. How long does it take that client to read the news feed? So the data that we're looking at here is, on the bottom, it's like it's that time, and then the y-axis is like the percentage of, it's like the histogram of where people fall within that bucket. And so on average, we're seeing about 30% faster on this particular provider looking at this metric. This is great for our users because that means the newsfeed loads faster, their pictures load faster. Everybody's happier when things are faster. You don't get people giving you 1-star reviews when things are slow. So then I said, okay, let's look at the same thing on Android. Again, I just restricted it to Android 4 and 5, the Galaxy S5 because it's like one of the most popular phones. Same sort of stuff. We see on average around 40% faster. I said, okay, there's another provider. They're single stacked. They can't possibly be using any v4. Well, occasionally it does for some reason. I don't know why. But again, the data that we show shows it's faster. And then same sort of stuff. So then I said, okay, let's see on this dual stack provider, what is the percentage of the users on this particular provider on Android that are using IPv6? So it's 88%. That's pretty great. But then let's look at iOS. It's a terrible 17%. And this is because of the Happy Eyeballs implementation on iOS. It's kind of this black magic sauce that Apple won't tell what it does, why it does what it decides. I've been told that it's done because it's better for the user, because if v4 is a millisecond faster, the user is going to care. Well, I don't think so. So we've been actively working to fix this, and so this is what actively means. So this is mobile Proxygen. So our web server that we use, that we've open sourced recently, is called Proxygen, and this is the mobile incarnation of it. This is basically our HTTP libraries running on iOS, and we jump from 17% to over 80% v6 usage on the same carrier using our own HTTP stack over iOS's stack. So the hope is to eventually open source this and make it so that everybody in the world can use a very high performant, fast, dual stack, but with a correct Happy Eyeballs implementation. And we still really have not rolled this out all that widely. It's a very small percentage. That's why this graph is very noisy. But it gives you the idea of how we're going to basically jump this provider's v6 usage significantly. And then again, we look at the iPhone 6 on this provider. Now we have client instrumentation. Now we're going to be able to do A/B testing of our users. So we'll actually be able to, once and for all, answer, is v6 faster than v4 by basically taking a segment of users, bucketing them into v4 only, and forcing them to and then another bucket to do Happy Eyeballs. But even without that stuff, we're seeing mobile Proxygen around 40% faster on iOS. So I can't tell you why we see this. Is it less congested paths? Is it different paths? Is the carrier grade NAT actually causing these problems? It's something that we're just starting to instrument. We're starting to experiment. Mark and I have been collaborating on this. And, we believe there's a win to be had here. And if there is a win, v6 is going to definitely make the user's experience better. So like I said, sometime this summer, we're probably going to end up doing a very large A/B test with a lot of users and once and for all answering this question. And even though we haven't answered the question, we, Facebook, have taken the stance when we talk to mobile carriers that we want them to roll more v6. We don't want to see more v4 proliferate. We believe that in the future, v6 is going to play a bigger role in the mobile space. Like I said, I think the desktop is mostly dead. We look at our v6 traffic, no enterprises are deploying it to their offices. So it's all home users and all mobile, and it's the mobile internet's taking over. So let's just focus there. And we want this because we want data to be delivered to the phone as fast as possible. That means a better experience for everybody. And if we have more v6 traffic, that means the Twitters of the world and whatever, they may actually deploy v6, which means more content providers. And then the other thing is with v6 on phones, you're going to have better peer-to-peer because you're not going to have to be punching holes through firewalls or doing crazy things to potentially get around. So that's our spiel on why we want it. And that's all I have to talk about.
That's a great spiel. It's kind of